xn plus 1 is equal to under root of 1 by 2 into 1 plus xn. Then what is the value of cos of under root of 1 minus x0 square upon x1 into x2 into x3 up to infinity, and x0 lies between minus 1 and 1. As I can see here, it is 1 minus x0 square with the under root. So I'll put the substitution here. Let x0 is equal to cos of theta, which implies x1 becomes under root of 1 by 2 into 1 plus x0, which is 1 by 2 into 1 plus cos of theta whole under root, which can be written as x1 is equal to cos of theta by 2, because we know that cos of 2 theta is equal to 2 cos square theta minus 1. From here 1 plus cos 2 theta upon 2 is equal to cos square theta. Using this identity here, we get x1 is equal to cos of theta by 2, because here it is theta, so here it should be theta by 2, the half angle, and the square cancels with the under root. Similarly, x2 becomes cos of theta by 2 square, x3 becomes cos of theta upon 2 cube, and so on. Now substituting the values here, we get under root of 1 minus cos square of theta upon cos of theta by 2. For x2, I can write cos of theta upon 2 square, and so on, so on, so on. For the nth term, I can write cos of theta upon 2 raised to power n, and it goes up to infinity. Since 1 minus cos square theta is equal to sin square theta, taking under root, we get sin theta. So numerator can be written as sin theta. So we know that sin 2 theta is equal to 2 sin theta cos theta. Numerator becomes 2 sin theta by 2 cos theta by 2. Cancelling the common and applying sin 2 theta property here again. In numerator I can write 2 as it is, and sin theta by 2 written as 2 sin theta by 2 square into cos of theta by 2 square. Cancelling common again. In the next step, denominator as it is. This 2 into 2 is 2 square. And applying the sin to theta here property, we get 2 into sin of theta upon 2 cube into cos of theta upon 2 cube. Cancelling the common. Now doing this process for n number of times, we will finally get 2 raised to power n into sine of theta upon 2 raised to power n upon cos of theta upon 2 raised to power n plus 1. But we know that n should tend towards infinity as the product is tending towards infinity. Now limit n tends to infinity. Sine of theta upon 2 raised to power n divided by this 2n can be written as 1 upon 2 raised to power n, and multiplying here by theta and dividing by theta, and cos of theta upon 2 raised to power n plus 1 as it is. Now this is a standard limit here, and it will tend towards 1. So we get only limit n tends to infinity theta upon cos of theta upon 2 raised to power n plus 1. As n tends to infinity, cos will tend towards 1, because for n tends to infinity, this becomes cos 0, and which eventually becomes 1. So we have the value of the limit is theta. Question is asking about the cos of this expression. So this expression we evaluated as theta. So this thing becomes cos of theta, and this cos theta becomes x0, because in the beginning we assumed that this x0 should be equal to cos of theta. So that's the final answer, which is x0.